Well, good
Well,
morning, good afternoon, good evening, good night to everyone, wherever you may be across our marvelous world. Thanks so much for joining us here live today for the one and only Serverless Office Hours, streaming on the AWS Twitch channel, on YouTube Serverless Land, and also via LinkedIn Live. My name's Julian Wood. I'm a developer advocate for serverless here at AWS, and I'm super happy to have the one, the only Andy Boothe, who's the founder of HumanGraphics. Andy, welcome to Serverless Office Hours.
thank you very much, Julian. It's good to be here.
Well, tell us about HumanGraphics and yourself. How have you come to be an expert in the world of Java and serverless, which we're going to get onto shortly?
Excellent question. So HumanGraphics falls out of about 10 years that I spent living as kind of an embedded developer building technology solutions inside of a large digital marketing agency. And one of the fundamental problems that every single company has on the marketing side is there's that famous chestnut, which is half of all advertising spend is wasted. I just don't know which half.
Yep.
So we always want to try and improve marketing efforts, right? And what HumanGraphics allows, particularly B2C or business to consumer companies to do, is to start with their mailing list and start appending demographics data to that. That is a surprisingly not common operation. And as you can imagine, the more that you know about each individual customer that you have, the more able you are to reason about what they might and might not be interested in to help you kind of dial in that marketing spend.
Okay, wow, that sounds fascinating. We're going to get on how Andy's built all of this using serverless architecture, specifically with Java. But yeah, just quickly looking back on the previous world of serverless on AWS. Last week's stream, super interesting. Two topics I love. Kafka and EventBridge, talking about a whole lot of streaming data, lots of information, high throughput and everything, and then combining it with EventBridge, where you're going to take those streams and maybe groupings of messages and split them off and do separate things with EventBridge. Really great ways to integrate with all of that. There was talk of protobufs and using CDCs and just lots of good technical details from Michael and Dave Boyne. That is on our Serverless Land YouTube channel, along with all previous other Serverless Office Hours episodes. So yeah, really great resource to catch up on a whole bunch of things. What's new in the world of AWS? Well, S3 has been doing some kind of things. Bottle Rocket is our container runtime. So S3, there's now a mount point for the S3 CSI driver, which now supports Bottle Rocket. If you're using EFS, we're going to be talking about AI ML today. Lots of people using EFS where they connected up to Lambda functions so they can share the same training data with multiple functions. Well, an extra bit of throughput wouldn't go amiss. So now 20 gigabits of second through throughput. And also Amazon S3, if you are doing machine learning, PyTorch is going to probably be familiar to you. And now you can use writing checkpoints with PyTorch Lightning. In terms of compute blog posts, based on last week's stream, similar approach, all about cloud events. So cloud events is a great industry standard for building an event envelope, and Dave Boyne goes into really good detail how you can transform cloud events to use it with EventBridge, back and forth, and really just makes it easy to be able to use an open standard with the event-driven architectures. It's AWS Summit time coming up. Amsterdam is on the 9th of April, coming up soon. I'll actually be speaking at the London Summit, so if you are around London, it would be absolutely great to see you. Lots of other summits. There are going to be more added to the list over this year, but a really great free opportunity to get a whole bunch of cool AWS technical content. More specifically, go to EDA Day, which is Event-Driven Architectures Day, is going to be running on May the 14th in London at CodeNode, so that's in the center of London. Everything hosted on event-driven architectures, focused on event-driven architectures, tripping over my words. We ran this about 18 months ago. It was absolutely packed out and a super useful day. So part 2 will be even more fantastic in London. So please sign up. Tickets are going quite quickly, so we'd love to see you there, and going to be a great day. That's sort of the past week, but today we're talking sort of about Java AI ML on Lambda with HumanGraphics. So Andy, you told us a bit about the HumanGraphics story. What is the story with, maybe talking about Java and AI and ML? This sounds like a lot of things all together, which sounds like a big problem. Sounds like it's going to be slow. Sounds like it's going to be inefficient. Sounds like it's going to be difficult. You're building a new company, and you're picking Java, and you're picking Lambda to do AI and ML. Sounds interesting.
Yeah, it was definitely a journey to get here, and there is. As always in any kind of technical build, there's a lot of variables, right? There's things that you can choose, and then there are things that are kind of chosen for you. And while Java and AI/ML is, not the most obvious match, right? In this case, it ends up to be an amazing choice from a cost perspective and a performance and scaling perspective, particularly because of SnapStart. And then in terms of why going serverless, I've got some, quick and dirty calculations that I can show you where, I was able to reduce just kind of server overhead by about 90% by switching to serverless. So, that definitely qualifies in the no-brainer territory.
Yeah, definitely. So was it, I mean, because you're familiar with Java beforehand, that was a natural starting point on your journey to serverless and may as well use the tools that you already know, or was Java specifically good for this AI ML workload you were building?
Yeah, so Java was kind of where I am a Java geek, right? Going way back in my growing years of my career. So I did start with Java as I kind of always do, just sort of prototyping things, and then I was building the machine learning models using Python, right? Just kind of the standard stack, and everything was going really nicely. And I was hosting things on large servers, and the large servers started to cost, as you can imagine.
As they do, yeah.
Right. And then I realized that kind of the more I experimented and the more endpoints I launched, which is to say the more models I needed to host, the more expensive things got, right? So I've got some slides to show if that's helpful, or I can just...
Yeah, certainly. Up
Okay,
to you,
great.
yeah. You're our guru, so we'd love to hear from you.
Groovy. And just quick check on the comments here. Okay, great. That's all.
Yeah, and also what I'll do is in the show notes as we're going along, I have put a whole bunch of links, and also I'll pop them up on the screen as well. But they are in the chat, so if you are connecting to via YouTube and still on Twitch, they will be in the chat, so they for posterity. And if you are watching in the future as well, all the links are available. So yeah,
Excellent.
Andy, there, I think it says as I've clicked, is that not quite appearing? The gremlin's been misbehaving. Let me just try that, add that again.
It should be showing PowerPoint. We can certainly make
Yeah, no, I'm getting a blank screen. Are you able to maybe just reshare that again, and we'll...
Sure, absolutely.
So this proves we're actually live and we're not doing all the slick edits. So, we will get these things sorted as well. Obviously, we're live, so please send us your questions and comments. We'd love to hear where you're from. We know, we have serverless developers from all over the world, so cool to connect with you. Let us know what you're building with Java. Let us know the cool AI ML projects you've got cooking in your back pocket.
I've also tried to just upload the slides here, so maybe we can do this without screen sharing.
Okay.
A second way here.
It's
processing, but just to kind of keep things rolling here, what I found is exactly what we were describing, right? So you start with kind of the bog standard solution, start with what's easy, start with what you know. There we go. Right, so this is what HumanGraphics does. It essentially uses cutting edge data and machine learning technology in order to allow us to append demographic information to individuals. There's a lot of other reasons why people might want to use it. For example, we have an emerging right to privacy globally. Using something like HumanGraphics, where the models were never trained in the presence of PII to begin with, means that you can kind of launder, so to speak, you can launder demographics information using PII. So you give HumanGraphics PII, PII gives you demographic estimates back, and you can store those next to your records with surrogate keys, and ta-da, now you're GDPR compliant.
Okay, because I mean that's something when I'm thinking about when we're talking about this, like, is there a bit of a creepy aspect to this, that you sort of scraping the web for people's personal information? How does one think of that when you're using AI models and there is information out there? How does one think about that? Because obviously for a business use case, you want to have good information about your sales prospects and your customers, but there is a sort of ethical line. How do you trade that with HumanGraphics?
The way I think about it is this is a decreepification technology. So everybody everywhere is trying to collect as much data about you as they can, right? What HumanGraphics allows people to do is to take the PII that you give them, right? So if you're checking out at a store, or if you sign up for a newsletter with an email and things like that, rather than going and throwing data at LiveRamp and trying to get a lot of that information, which is expensive and very precise, but to your point, Julian, creepy, right? What HumanGraphics allows you to do is to take that information and then get demographic estimates. And demographic estimates, these models were never built in the presence of PII. There's a model for recognizing first names, a model for recognizing last names, and so on. First names are not PII. First and last name is PII. But just because I know you're Julian doesn't mean that I know you are Julian Wood, right? So using those demographic estimates, we can get a very good estimate of demographic information, age, sex, race, that kind of thing, even location, all from a name or an email address. But they are estimates, right?
Okay, and so it's sort of anonymized. It's not actually finding information about me. It's finding what my name or the information you do have would tell about somebody like me, which can then help you to do kind of things with the information of the kind of person I am, not the actual person I am.
Exactly right. The goal is to create predictive signals without actually requiring PII.
Okay.
So that maintains the marketing utility, and in cases like GDPR, that's really important, right? Where you're not even allowed to really store or process PII anymore. You can maintain those predictive signals all without worrying about the PII data that you have. So we started with architecture Mark 1. Here's your classic Amazon Web Services architecture, but we're all grown-ups here, so this is the architecture, right? User talks to an application load balancer, which talks to Fargate. Classic web application, right? Classic API. In terms of the business outcomes, it totally works. That's outstanding. It's just a Java application. I can do whatever I want to do. From a performance perspective, I can scale to the moon because I'm using Fargate, as long as you tell me 5 minutes in advance, right? So if I get a spike in processing, I have to wait until Fargate will go and create those new. I have to wait for the metric to trigger. Then I have to wait for Fargate to respond and create those new containers. And Fargate is outstanding. Don't misunderstand me. But it does not scale in truly real time, right? It's not truly elastic in that way. It's not immediately responsive. And from a cost perspective, we're not in good shape here, right? So every model goes on every server, and you're paying for uptime. And the more models you have, the more server space you have. And whether it's one big tall server stack or a bunch of shorter server stacks, it doesn't matter. The economics are the same, right?
But you were starting with a partly serverless stack. I mean, you were using Fargate. I mean, that's a modern container hosting service. So I mean, you're actually even sort of starting from the gate, not sort of
true.
EC2 Classic or something in the.
And I forget that. Fargate is so good. I don't really build anything without it anymore. So it's easy to forget that that's actually serverless, right? For me, that's just like, EC2 used to be cool. No, now Fargate is cool. Thank you very much. So it's easy to forget that that's serverless. But the feedback from potential customers was, man, this is great data, but I need more, right? So my rate limits were too low. That's a problem. And the inability to scale elastically was causing that problem. As an architect, if I'm wearing my architecture hat, scaling was a limiting factor for future use cases as well. I wanted to be able to do batch processing, for example, and just couldn't do it. And if I wear my finance hat, I'd really like not to live in a cardboard box on the side of the road. That's too expensive, right? So basically, I ran the numbers, and we can't afford the cat. I mean servers. So here is here was a nice little Amazon calculator in terms of just estimating the cost here. Obviously, I've just gone and plugged in numbers here, but just in terms of what I was running at that time, my estimate was about $600 a month just to keep the lights on, right? That's before processing any requests or anything. So we can do better. And the answer is, ta-da, serverless, right? It's a good thing, this being serverless land. Boy, would my face be red. But that brings us to architecture Mark II, going truly serverless, not just Fargate, where we have servers that we're spinning up and spinning down, but truly serverless. So our architecture Mark II here moves from application load balancer to Fargate to an API gateway to Lambda, right? So in terms of our business problem, we still want to be able to host multiple medium horsepower models. It's got to be very, very scalable, very, very elastic in real time. It needs good enough performance and much lower cost. So this is kind of what we were opting for from an architecture perspective. And then I've got my... Okay, so sorry, we got the wrong set of slides uploaded. It's just a slightly back-leveled version. That's okay. So the upshot is there are a series of challenges associated with that, right? So the limits are things like your API gateway only allows you to run for 30 seconds. Can we tolerate that? Your API gateway has tight limits on how much data you can exchange back and forth in your request and response. Can we deal with that? But the real deal breaker was, from a Lambda perspective, these machine learning models are not small, right? They're not huge. I'm not hosting ChatGPT or anything, but they take 30 seconds to load, and it's hard to get much faster than that. And Lambda doing the cold start thing means that we're going to pay that every time we have a cold start. So how can we work around that? The answer is, ta-da, SnapStart. So SnapStart is the bee's knees. Here is Mark Sales on stage talking about SnapStart at reInvent. It uses something called crack coordinated restore at checkpoint snapshots, which basically snapshots are running JVM, gives it a bottle, gives it a blank, he puts it to bed, and then allows you to wake it up at any time, and it'll be in exactly the same state as when it went to sleep. And just visually what that looks like is this is kind of without SnapStart, right? So all of our cold starts are, the program initialization is paid every time on every cold start. When we add SnapStart, You can see that we move our program initialization from every call to just the deployment. So we pay it once and then never again. Just kind of visually, that's where that goes. That is an enormous change. It's revolutionary, right? The problem is that you can only have up to 10 gigabytes of memory, right? Because we're talking about Lambda here. And SnapStart requires that we run on the standard Java runtime, so no container shenanigans. And I can only run with 512 megabytes of ephemeral storage. So I can't even scale up the disk size. So under all those limitations, here's kind of the plan, right? So we're going to switch to serverless for hosting our API, which gives us a lot more scalability. That's awesome. We're going to use SnapStart to reduce our cold start from like 30 seconds to much less than 5 seconds. That's amazing. We'll just host our machine learning models in Java. That's not the best, right? Rats. So there is the wrench in the monkey. So here is all those challenges that I mentioned before. Basically, just how do we run a machine learning model with all of those constraints? And that takes some chugging. So it took about 3 weeks to crack the code. But after all of that, the answer ended up being byte deco and then something I call temp dump. So here's really how we run AI and ML on Lambda. So the Lambda if we think about Lambda storage, there's only so much storage available, right? So we have 256 megs in our deployment stack and any layers that we have, 512 megabytes on disk since we have to use SnapStart. And then we've got 10 gigabytes of Lambda memory. And I have to fit all of this stuff in this small package. So the way I ended up thinking about it to keep things simple was I want to give all 256 megabytes to our program, right? So the application can be as big as it wants to be, up to 256 megs. There's a teeny tiny layer here that I have to have that's under a megabyte that does some customization to the underlying Lambda runtime. And then from there, because we actually want to run our machine learning, if you look at all the Java machine learning libraries, they're all bigger than 512 megabytes. So, and because all that has to be on disk when you're kicking off your program, we can't use those. So we're going to have to use some kind of native solution, right? We're thinking OpenCV, TensorFlow, stuff like that. The way that that works is we want to load at application load time. So during initialization, we want to download all that stuff, which doesn't fit on the application because it's potentially 512 megs. It doesn't fit in your application deployment package. We're actually going to download that from S3 before we launch the JVM. And then we launch the JVM, which contains the actual core program. It will download the model. And as long as that fits in your 10 gigabytes, then I can use JNI to go and talk to OpenCV and TensorFlow and things like that. And that's how we actually run it. So essentially, we have to use Java because we need SnapStart. Then we can use some clever JVM stuff in order to essentially load all of our native solutions into the ephemeral storage, download the AI/ML and get JNI linking it all, and then Java essentially just becomes a coordinator, right? So that's fundamentally how it works.
So yeah, for people who are also thinking, well, hang on, temp space can be up for 10 gig. That can be, but not when you're using SnapStart. So also to rewind back, SnapStart is when you're going to take a snapshot of the running machine, run the init. Yeah, you had a good thing over there. But snapshot takes the running machine, creates literally a snapshot of it and saves that to disk. And then when the initialization comes in, a future initialization comes in, it just warms it up. There's no installation, there's no running or anything. It just can present that running virtual machine live, which can take under a second, which solves your cold start problem. All fantastic, except there are some coordination things that need to happen. And unfortunately, today we can't export, we can't use the extended temp functionality, which for other runtimes can be up to 10 gig. So that's why if you're thinking, oh, I know Lambda 10 can be up to 10 gig. Yes, it can. Not quite yet when you're using SnapStart.
Yeah, thank you, Julian. That's exactly right. So essentially, as soon as we said Lambda with SnapStart, it means Java, it means 512 megs, and it means that you can have 10 gigabytes of memory, but that's it. And that you need to move all of your initialization to essentially before the JVM actually launches in order to get all that nice, tasty SnapStart quickness. So that's why we're doing things this very specific way. Yeah,
so all of this cleverness is to basically take advantage of the storage, the sort of bounded storage that there is to do that. I mean, was EFS ever a possibility?
I don't believe that you can use EFS.
Oh, you can't use EFS with SnapStart as well. There you go.
Yeah. So it was, yes, I happen to like Java, but I didn't just do this because I like Java. I did it because it was literally the only way within the constraints of SnapStart as it's working today. Now, I suspect that over time, SnapStart is going to allow you to use more ephemeral storage. That simplifies this, right? Wouldn't shock me if over time SnapStart allows you to use EFS. That would simplify this, right? There are a lot of things that could be done to SnapStart that would simplify this kind of workflow and process. But for now, this is what we've got.
But the point is you can do it for now, yeah. And
exactly, right.
But the big thing is to actually have a big machine learning model, but drastically reduce that cold start time, because it's going to be behind an API. And so that dictates SnapStart, and then, creating some cool sort of storage funkiness behind the scenes to make that sort of an abstraction.
That's exactly right. So, for now, this is what we have to do. These are the hoops that we have to jump through. And remember, I said before that we have to host, the more models that we add, the bigger the servers we need, right? Well, that problem still doesn't go away. So using this approach, I was able to load one model, and I was able to run my Java code, and everybody was happy. And what we ended up with was we have users talking to our API gateway, and then I have one Lambda function per endpoint, right? But some of these endpoints require 4 machine learning models, right? We're actually combining multiple models together. And so the first model works really well in that Lambda function. But when you start adding the second and the third and the fourth, those aren't going to work. So we need yet another ingredient into the mix here, right? And that's express step functions. So express step functions are special step functions that allow us to, that can be called from API gateway, that allow us to do some very specific kind of orchestration tasks, Lambda being one of them, thankfully. And so we're going to orchestrate like Bugs Bunny here.
Yeah. So that's just when you were talking about Java being the orchestrator. Are you sort of taking some of that orchestration out and using it in step functions? Is that sort of the mental model people should have?
That's exactly right. So before, if we were going to try and use 4 machine learning models in one Lambda function, you do all of your orchestration in Java code, right? Oh, thank you, Shiltube. Appreciate that.
Shiltube. Yeah, we've had a clap before as well from Shiltube. Thanks for joining us via Twitch. We appreciate the feedback. Thank you.
Sorry, I'm doing all this on one screen, so I can't see everything all at once.
No, I will bring them up.
But so this was our architecture too, right? So we tried to do 4 machine learning models with all of our orchestration in Java. That works, except you run out of memory, right? So now we move to our kind of Mark 2.1, where each Lambda function has at most 1 machine learning model, right? And then we're using our express step functions now to just orchestrate and call those Lambda functions in sequence. So now we're able to do all of that. So here's an example step function that's really, really simple to parse a human name, receive your input, do a little pre-processing, populate some defaults, things like that, go and call Lambda. Super simple. Here's one that's a little bit more complex, right? So if we're going to go and talk to Twitter and then pull that back and go and look at profile pictures and human names and location fields and things like that, there's a little bit more orchestration in play, right? So some of these workflows are not just trivial. But having gotten here, right, starting from we're going to use Fargate and growing our servers and things like that, and that's really expensive, all the way here at the end of the story to we're using API gateway to express step functions to Lambda functions. Functionality is still 10 out of 10. I can still build anything I want. There's no limits here. I have to organize it a little differently, right? But that's not a problem. The performance is 8 out of 10. Instant scaling, acceptable cold starts, right? So it's never going to be as fast as having a server just sitting there waiting for you, but it's really not that noticeable, particularly on the second call, right?
And are these all behind synchronous endpoints, or is this an asynchronous process that a user's not quite waiting for the input? Because then cold starts don't matter as much.
It's true, yeah. So right now everything is synchronous, is the way I've got it structured. So everything can run in 30 seconds or less. Users that option. Okay, great. Sorry, I saw myself. I was afraid I lost my connection. I definitely, on the future, want to build. I have bulk endpoints which allow you to parse 10 names at once, for example. The next thing after that would be batch endpoints, which is when you just upload your Excel sheet, go get a cup of coffee, go have a sandwich, go have a nap, come back, and I'll email you when it's done, right? So that's definitely somewhere that we want to be. And the cost is, on kind of Mark 2.1, our cost is an 8 out of 10. I want it to be free. It's not free, but it is very, very cheap. And then feedback is so far so good. I've already been able to increase rate limits by 5x. I think we've got headroom for another 2, so that's probably 10x by the time we're done. scaling is no longer a limiting factor for future use cases at all. So when I got my architecture hat on, I can do, I can plan now for a completely different set of services like those batch endpoints, and a substantial cost reduction. Let's see if so the second calculator didn't make its way in, but now I'm spending, instead of about $600 a month, I'm spending about $60 a month.
Wow.
And yeah, it's 90%, right? It's an order of magnitude.
So those what is actually the rate limiting? What is actually the limiting factor within the rate limit when you can say, you're 3 to 5x higher with headroom for another 2x? What currently defines that rate limit?
Right. So when I was on Fargate, and it was going to take 5 minutes to scale, right, to scale up in practice, you have to limit the rate limits pretty aggressively, because if everybody spikes at the same time, you're going to have a bad time, right?
So it depends how many customers are currently using your service, which dictates the sort of the bounds of your scaling.
That's right. And right now, when there are periods of time where nobody's using the API right now, because we're still a growing business, obviously.
Yeah.
We just can't afford to have servers sitting there doing nothing, right?
Yeah.
Now, you can imagine a future where we've always got kind of a baseline of activity. All right, maybe I spin up a couple of servers. As long as the utilization is above 50%, I'm a happy guy. But then if that utilization starts spiking, I go off and do kind of a Lambda option or something like that while I'm waiting for Fargate Spot to kick in, for example, right? So it's kind of a hybrid approach you can imagine there as well. In terms of the 5x higher right now with room for 2x, mostly I'm just getting experience with this new implementation and how it scales. So far, do your worst and it just keeps smiling, right? But I'm not going to give everybody 100 requests a second, because for one thing, I don't want anybody to have a bad experience using the API. For another thing, I'm also just, we also have to figure out the pricing as well. So it's not just a technical question. So in those terms here, that's kind of the whole story. Now I've got, code and blog posts and GitHub repos, and we've got interactive documentation all up there. So I'm very happy to, we can kind of go here wherever the audience wants, and show too. Outstanding. I've got an open source repo with all of the customization to the Lambda runtime.
Yeah, definitely. So I mean, that's a HumanGraphics docs page. I'm just doing the links that over there, and there is a GitHub organization as well for HumanGraphics. Shiltube says thank you very much, Andy, as well. And that's a sort of GitHub org for HumanGraphics. And I'm not sure how prepared you are. I don't want to just chuck you under the bus. And we do have a sort of another half an hour. Is there anything you'd like to sort of show of actually how it works, or what the sort of experience looks like?
Absolutely. So can you, Julian, can you share the API key from the private chat to the comments there?
Yes, certainly. Do you want me to share that publicly just before let me check?
Yeah, it's public. So that just for the purposes of this conversation while we're talking here, that is a completely unlocked API key.
Yeah. I just want to make sure before I'm sharing.
No, absolutely, right. It's bespoke. I spun it up for this discussion. Sorry guys, I will turn it off, within an hour or two after we're all off here.
Yeah.
But for everybody to enjoy.
Cool. No, fair enough. I will put that up just before we get there. Brooklyn Man, hello, Brooklyn Man. I presume you're from Brooklyn, so welcome. Thanks for joining us via YouTube. How well does a cold start work? Are you using a injection framework like Spring, or are you constructing everything by hand? You have to fiddle around a lot to get the cold start working well.
SnapStart. Okay, so SnapStart is completely transparent, it turns out. So the nice thing about the way that SnapStart has implemented that crack technology, the coordinated, I forget exactly.
Something and restore coordinated.
Yeah, coordinated restore and checkpoint. That's it. You got it. So the way that works, it's all built into the JVM and part of the JVM technology. So the way that if you actually go and read the code, and part of that's actually copy pasted to my GitHub repo, which is all according to the license. It's okay. It's all open source anyway, so you can go and look at it. But if you look at it, what the actual Lambda harness does is when the application wakes up, AWS Lambda runs, it kicks off its RIC, its client, to go and essentially receive. It wakes up, it does program initialization, which goes and creates your handler. So it creates the object, and that kicks off all the static initializers and things like that. And your classes gets ready to kick off the RIC, the client, to go and request go and receive requests to execute in Lambda. And right before it does that, it makes the call to crack, which again is a built into the JVM. So totally standard, OpenJDK supported, right? Not a backdoor at all, like fully well supported JVM technology. And from that perspective, it's very much like running an exec call in C, right? From your perspective, your control flow continues unchanged. You would never know you called it, except that now now you happen to know that you might be in a completely different process that has been woken back up from JVM state. So it's very easy to use SnapStart. You don't even necessarily have to know you're using SnapStart. The only thing about it is if you have any persistent connections to things like databases, obviously those connections, because you're running on a completely different server and a completely different process, you need to be aware for that. But the way that Lambda runs it is super smart. You don't generally even really have open connections at that point because you're not processing requests. So totally transparent. Hopefully,
and we do actually have and we do also have a Java replatforming guide, which is on Serverless Land. Mark Sales, our absolute guru for all things Java, along with Max Shellhorn, have put this thing together, and that's got lots of things with considerations of taking a Spring Boot application that maybe was running on-prem or on an EC2 instance, and some of the factors that you can use to replatform that to AWS. Yeah, and that's one of the interesting things. I think Andy hit the nail on the head that SnapStart is meant to be as transparent as possible. If you think of other runtimes, maybe like .NET or other kind of runtimes where you need to have an AOT optimized version to get, or create a binary, and that's the way to solve the cold start problems. Java doesn't have to do that. And in fact, you actually have to worry less about the cold start, because if it does take a little bit longer, you're taking it way before the init. You're taking it way before even, in effect, you are publishing the actual function. So you don't, in a way, have to optimize your cold start. You just turn on SnapStart, and we had the exact thing I was going to say. Wheatlol, thanks for joining us via Twitch. Sorry, the wrong in the order. Is that it only works with published versions. So we have a lot of customers, unfortunately, who turn on SnapStart and then don't target a published version, and they think SnapStart's on, but nothing's happening. This is the reason why. So you really have to be using a official Lambda runtime, as John said earlier, and use that functionality, and that's what going to make it really simple.
Yeah, and just real quick, the failed to post. Sorry, I'm trying to drop a link to. Okay, well, I cannot drop a link to the GitHub repo if you haven't already.
Yes, I will do that again. I'm sure I have it.
But because those runtimes are open source. Sorry, not the organization, the actual repo.
Yeah, I'll put that in.
Okay, thank you. Because all these implementations are open source, you can actually go and build them yourself. And in particular, you can look at the way they work, and you can load layers, and you can inject a custom runtime script that allows you to essentially treat this standard Java runtime as your own little container sandbox, and everything still works. Ask me how I know. So even though you are limited to only the official runtimes, you can get a shocking amount of control over that runtime to do very clever things with SnapStart.
Cool. And one of the reasons people do ask is, well, why is SnapStart only available for Java? And the reason is because we've done the work with the Java community to be able to do the crack system. We actually specifically didn't want to build something just for Lambda to be able to do the snapshot and restore. So it was working with the Java community that it's a purely Java thing that does the snapshot and restore. And so that's why you're wondering, well, why isn't SnapStart available for other runtimes? We're working like heck on it, but we don't want to make it a Lambda specific thing. It wants to be a native hook within the actual language runtime, and Java is a bit more advanced with that. Good on Java, and so that's the reason why. And you also may wonder, well, why is that important? It's just about creating the snapshot and the restore. Well, actually, it's about randomness and about security, because we've got this concept of when you restore something, you want things to be safe. You don't want to have a random number generation or some sort of secure thing that you're now going to spawn, a million Lambda functions, and they're all going to come from the same seed image. You're going to have some issues to do with randomness. So that's what it's all about, is just making that restore process as safe, secure, and predictable as possible.
Yeah, because you can imagine how much simpler this would have been if, for example, Python had that same kind of approach, right? I don't have to worry about building this whole JNI layer and doing all these customizations. But sorry, my politics are showing a little bit. As usual, Java's ahead of the game. So it's very pleasing to see this feature.
Excellent. Well, I've published the custom API key, so we put them on the screen. So people are watching in the future
There's
in the
no going
recording.
back.
not quite over there. That's why it's lovely if you join Serverless Office Hours live, because you get to play with custom API keys live on the internet.
All right, so let's see here, just real quick. Let's go in.
Let me just think. There's actually also, if you are wanting to do Java on AWS, there is actually also a workshop as well. So I'll just put the link up to that, and I'll come back to that API key. So yeah, this is this Grace build cloud native Java applications on AWS Lambda. Yeah, whole workshop. I love doing workshops. It gets your hands on with the code, and you can actually go through everything that is happening. Am I doing? Yes, it looks as though we've got the right screen.
Outstanding. All right, so if you copy paste that bearer, so if you go to docs.humangraphics.io, which Julian also very helpfully shared earlier, you can take that bearer token and you can put it into the authentication page here in the docs, and that makes the docs completely interactive. So we can come up here, for example, we can test parsing a name. So I just click that test request after pasting the bearer token, and it's got a sample body here. Everything's completely editable. And if we wanted to go and parse Fox Mulder with a country hint of US and try to figure out what his demographics are, what we get here is a confidence of about 95% that we've parsed that name properly. That name is parsed from Fox Mulder into a name template of given name followed by family name. The given name is a single name as opposed to a double barrel name. That the match text was Fox. No middle name given, no nickname given. The family name is Mulder. It's a single name, single barreled family name. There's a shocking amount of variability in names across cultures here. We're able to determine very confidently that the gender is male, and we were not able to get a nice age or race estimate, unfortunately, because most of the Fox Mulders, it turns out, live in the Netherlands. How about that? So we can also get, just based on the prevalence of those names, an estimate on where in the world people live.
So that is literally just giving a single name as, you connecting to the API. In your text, you're just doing a name and a country hint, which may be, if
optional.
You know your customers
Totally
from the
optional.
US, which is optional. And this is now using machine learning model and gathering estimates from all these other kind of things, which could be interesting.
Yeah, and now I've just put my name in here, and now because it suspects that I live in the U.S., most of the Andy Boothes live in the U.S., we can get an age and a race estimate. Would that I were under 18. I am not, but it's correctly sussed out that I am male, and yep, hi, white. No avoiding that. So you can kind of see here in terms of why the parsing names works, and then we have endpoints here for parsing names in bulk. If you believe you have more than one name, for example, in a research paper, we can actually split those names apart. If you have the name already parsed as first name, last name, we can analyze those. And then in addition to that, just for this talk, I've also got some beta features here that we can try out. So we can use these new beta endpoints, which are designed to work with social media profiles that allow us to go and, for example, on Instagram, let's see here, what's a good one to use on Instagram here?
It's actually, Vitlol says, how much does the country hint input approximately affect the results of the country estimate in the case of Andy Boothe?
Excellent question. So right now, it's Air Network, which is why this is beta. So we'll get that working, but right now it's a 2x, so it will double the likelihood of the country that's given. I'm still fiddling with it. I haven't determined if we should just say, if someone gives a country hint, just say, hey, they're from the US. You say that it's from the US, I trust you, or if we should double it or 3x or 5x. We could also, add another parameter yet that would allow us to give a little bit more control over what that hint looks like. So you can check out these interactive docs here to kind of check out the API and what it does. And then in addition to that, if you don't want to play with the beta stuff, if you just want to kind of more visually see what's going on, I know we're all developers and so we like to live in the docs, but if you want to see more visually what's going on, you can also hop over to humangraphics.com/test drive. Still failed. Sorry, Julian.
That's right. But actually, reading on your website, it was fascinating because obviously I was looking at this and going, okay, you're fine, easy. You're going to get a name and you're going to, grab some estimates. You can see over there, age and gender and all these kind of things. But on your website, you had these 3 fascinating articles, which was just called "What's in a Name." And even if you're not into, estimations of where people are from, whatever, it's actually, we think as Westerners, or even I live in the UK, you live in the US, that we sort of understand what how names are generated or how names works. I didn't at all. So it was a fascinating read of the whole social aspect of naming across the world. Yeah, fascinating.
Yeah, it turns out that one of the hardest tasks in managing kind of names and parsing them and getting them to do work for you is much less about collecting the data. The data is out there. The problem is structuring it. So how do I create a structure for a name that I can build a machine learning model on that will adequately represent not just names from the United States, but also names from, Mexico and Africa and Europe and around the world, right?
And even I think, what was it, Indonesia, where people only have a single name? Yeah.
Yeah, exactly. So in Indonesia, there would be Andy, right? Obviously, there probably aren't a lot of Andys in Indonesia, but there would be Andy, and everybody would just kind of know who that was. And so you just kind of you have your given name, and that's sort of that.
That defines you. Yeah. And I mean, we don't, some even cultures, I think when we work in IT and you understand different people from different cultures, that, first names and last names are inverted in different kind of places. And yeah, you just think it was such an interesting read, thinking when I interact with people from other countries, to be understanding that their names are different. And, we understand that I'm going to get the names wrong probably because I'm going to call someone by their first name when actually their first name is not their first name and the last name, or the other way around.
That was one of my favorite features to build actually for this, which is it turns out that for Asian names like Shinzo Abe, for example, in Western cultures, we use the given name first and the family name second.
Yeah, Shinzo would be your given name, would be Julian, and Abe would be Wood. Yeah,
exactly right. Whereas
not that I'm saying I'm from Japan and the Prime Minister of Japan or President. But,
exactly, yeah, former Prime Minister of Japan. Exactly right. Yeah. So whereas in Asian cultures they do it the opposite way. So, when you just see a name written down, how do you know which tradition that it's using? And the answer is you have to have a great big list of a bunch of first names and a bunch of last names from that culture. And then you take your best guess, right? Now, the good news, it's fortunate that in Eastern cultures, there are a very small number of very popular family names. So you can actually get quite a lot of mileage from just a little bit of data. But once you get down to the, below 80%, and you start trying to guess that last 20%, you need a lot of data, it turns out.
Yeah.
Yes,
and I'll put the link to the test drive on the HumanGraphics website as well, because that is also useful to be able to do that. I mean, even while we're looking at the demo, I think I certainly glossed over how quick the responses were, because you were just doing an API request, you put Fox Mulder, you did Andy Boothe, you could have done my name, for example, and you are now behind a synchronous API calling not just one Lambda function, but a step functions workflow, which is coordinating a whole bunch of different Lambda functions, if I understand correctly, with a whole bunch of different machine learning models, which is storing, up to 10 gigs worth of data in memory and then returning the response as quick as you did. I mean, the speed was, in fact, the speed was, I take this in the best way, the speed was unremarkable because you didn't remark how fast it was. And
most of the time, that's our goal in IT, right? Don't get noticed.
Yeah. And I mean, even I was using some, AI, generative AI service earlier today, and I was asking a question, waiting for the prompt response to come back. I mean, that took, 20, 30 seconds. And I know that's generative AI, that's creating something that's slightly different. It's not just doing the inference, but yeah, this was noticeably quick.
And that's just a testament to, from my perspective, AWS. Yes, you have to be mindful of how you use it, right? Not everything works. Not everything is going to work every which way that you want it to. But, in terms of, if you use it right, AWS is, what an age to be a software engineer, right? Look at the stuff that we can build and the platforms and the tools that we have to play on. Like, you couldn't build stuff like this 10 years ago. You just couldn't do it, right? You'd have to have a whole team focused on solving the infrastructure problems before you ever get to write the application, right? Now I just get to walk up and swipe a credit card and pay like $50 a month and get access to all this stuff. Come on.
Yeah, I think as you bring up step functions, one of the great things about step functions is you can visually go through execution and see exactly what's happened. I mean, from a debugging, understanding, perspective, that's powerful.
Yeah, and even though, so one of my reservations in using express step functions, of which all of these are, right, because we're calling them from an API gateway, one of my reservations was that I wasn't going to have that really nice user interface that allowed me to go and see all the executions, because it's all logged to, you are warned ahead of time. This stuff is all logged out to CloudWatch. But, as usual, AWS exceeds my expectations. Again, sorry, showing my politics, but you can see here very quickly all of those executions because AWS has parsed all that out of CloudWatch logs for you, right? So when I ran that parse name that you saw earlier, the input that we received was, so I can see here people are using the API. That's amazing. Sorry for revealing a name there, but we're looking at the input, and that ran for much less than a second. It ran for 0 milliseconds. Our Lambda invoke, which took as input the name, and then as the output produced the literal output, right? Which again is working based on those machine learning models. That ran for 100 milliseconds, right? And that was it. And then API gateway and things like that are all running behind the scenes that quickly. So it's amazing the tools that we have now, right? That we can put together, and knowing that all of that is churning through these huge multi-gigabyte machine learning models that have all been loaded behind the scenes and SnapStart and things like that without really any work from me is just fantastic.
Yeah, it's fantastic. And in fact, I was just putting in my own name as Julian Wood, and it said I was male, said I was actually from GB, and even though I'm originally South African, I live in the UK, so maybe some family connections back to.
I swear it didn't look you up. So I just go to Spokio and make a call there, and no, it's just statistically.
Exactly. So two things. I love looking at the step functions, and if I would really encourage people to look at step functions from an orchestration perspective. Andy's here is just orchestrating different Lambda functions, but think of the possibilities when you need to orchestrate other AWS services, especially when they're just SDK calls within a Lambda function. That can just be natively done in step functions. And wisely, Andy has used express workflows because also they are way cheaper. They can only run for 5 minutes, and they don't have callback tokens, but that's fine for these kind of synchronous requests. So yeah, step functions, express workflows is a really much cheaper way to even run some of these powerful orchestrations. One other thing I wanted you to just mention is there was some clever hackery you did within your Lambda function to actually get this to work. If you wouldn't mind delving into that, I think that was super interesting.
Very happy to, and also just showing off X-Ray, just because again, when you use these tools, it's just there's such a wealth of information that it makes available to you.
Yeah, so you've got your visualization in step functions, which is all fine. But if you were then connecting to a database or another API or another account or that kind of thing, this X-Ray is going to show you the whole end-to-end view of your application.
Exactly right. So how much time did I spend in my API gateway? How much time did I spend in the inside of that processing and things like that. And just in terms of a documentation, right? How do you build a service map? Go to X-Ray. Here's your service map, right? I don't have to worry about onboarding someone. And, it would be polite if I did document these things, but if I didn't have time, because we're all moving fast, at the very least, I can avoid someone here. So,
and this is dynamically generated. And actually the super clever ways to even use this X-ray with the traces is actually put custom metadata and annotations within the traces you generate within your Lambda functions, because instead of having to then delve into the logs to find out what was the calling service or what was maybe an input payload or that kind of thing, you can annotate that directly within X-ray, and so you can dive into the individual trace across multiple services and find a microservice name, a customer name, depending on whether you want PI information or what. So yeah, you can actually have that traditional log / maybe some metric information directly within your traces, which really helps with that observability taken into the next level.
Definitely, and start throwing some of that information in CloudWatch logs as well, and you can use CloudWatch log analytics and do real time. For was it like 80 cents a gigabyte? Come on, what a fun time, man! All right, let's see here. So I'm in GitHub, and this is our layer. Okay, so we talked about how we were doing some shenanigans on the standard Java runtime.
And that is a technical term, shenanigans. Just in
case it is. You can look it up. It's in the advanced algorithms book that everybody has on their desk. So this should be a public repo. Everybody should be able to see this. It's HumanGraphics /backend-lambda-layer. And I mentioned earlier that if you looked at how the SnapStart is actually implemented, this is one file copy pasted from the open source implementation, and there's a lot of really fun stuff that you can go and for example, we were looking at the X-ray stuff. This is where all that's managed. But if you can come in here to actually look at it, and if we go and find, Yep. So here's the actual, if anybody's curious, here's the actual entry point for Lambda. So this is the actual main function where we do start runtime and things like that. And you can look at how it sets the input streams and the output streams. So if you're ever curious about Lambda internals, it's right here. You can just look at it. You can also go and look at the Firecracker VM. I don't know if they've upgraded to Bottle Rocket or if it's still Firecracker under the covers. I think Rory built that. He's no classmate of mine. Brilliant guy.
So this isn't specifically HumanGraphics. This is literally looking at the AWS Lambda implementation of the runtime interface client and how that interacts with SnapStart. Okay.
And here is where we call SnapStart. So init type SnapStart equals initialization type. So literally, if that's part of your environment, you just on init complete. Ta-da! And then we're snapshotted afterwards, right? So this was the implementation of SnapStart, plus all the other stuff they had to do inside the JVM, right? But it's not even my code. I don't even have to see it, right? I just have to be aware that maybe some connections, if I have any alive, might have gone away.
But this is, I think, an interesting meta point that you also make, is that a lot of people sometimes feel a little uncomfortable maybe using Lambda because they think it's special, they think it's different, they think it's some crazy fork of Java, or never mind Node or Python, or all these kind of things. But the actual the Lambda service literally runs a pretty simple API called the runtime API, and it's a continuous loop, and all you can do is get the next event and you can send the response and an error. That's literally all the API can do. And the client on the side, which Andy is walking through, is available with all the runtimes. It's entirely open source. And so the part that your customer code connects to is a client which is fully open source, which talks to an API that literally is an infinite loop that gets an event and sends either the response or sends an error. And that's literally from your customer experience of interacting with Lambda. It's, that's a huge bunch of stuff that's open source and available. And, it's nice that customers can look into that and have confidence that we're not doing anything crazy behind the scenes from the code perspective. Yes, behind the scenes, instead of spinning up those execution environments, trillions each month across all availability zones, across all regions, yes, that's behind the scenes, but your code really isn't interacting with that.
Yeah, and I also just want to point out one other thing, which is I got invited by AWS to talk about this architecture to show how you could totally jack around with their technology to save 90%. Who else does that? So that's amazing, right? Like I'm being invited here to show how you can totally, subvert is probably too strong a word, but I'm definitely deep in the internals, right, of this open source implementation, and I'm showing how you can use it to your own nefarious ends to save 90%. So it just, the culture is amazing as well. But one other really neat thing about, little known fact about, well, I think little known, but maybe not little known thing about Lambda is you can also set it up with a special environment variable, which I think I've documented here somewhere. But I should have all the documentation here and pointing to the relevant documentation. If I don't, I will do that right after this talk. But you can set a custom entry point, and in this case, the original entry point for Lambda is hilariously just a shell script. So I just made another shell script, and in their shell script, these were the default set of environment of parameters that they were using. For me, I just wanted to check the environment. This is where I do the temp dump, right? So I use that very same Java runtime that's sitting in our Lambda install, along with the runtime interface client and other dependencies to make sure that it runs, and then a custom application to go and download our S3 file, right? So this layer here just has a super lightweight S3 client that I wrote that allows us to go and pull down whatever the native application that we require is, and go and put it into the temp directory. So and then rewrite some of these arguments to get a little bit better performance. For example, I turn off tiered optimization, the tiered compilation, because it dramatically reduces your cold start time. And then we just go and kick off my customized version of the AWS Lambda entry point, which is only very lightly customized because I needed better control of the class path than the original implementation would give me. And then if we go look at that temp dump, which
this is the hacky bit that you basically, just before the Lambda runtime starts, you are having a little shim that's going to download the machine model data from S3 and is going to load it in memory so it's available to use the 10 gig. And then you're going to run the Java runtime with some optional parameters to speed things up and do some customization.
That's right. So the shim goes to S3 and downloads. It's actually not downloading the model. It's downloading like OpenCV, or it's downloading something like that, because that's bigger than 256 megs. It can't fit into your deployment package
size.
Yeah, exactly. So we put it on in temp so that it's actually installed in there so that when we start the JVM to do the real work, it's there for JNI to link to.
Okay. Yeah.
And then inside my application, which, this layer is not that, but inside my application, I just go and download the model in memory inside my main application. But you needed to be able to download that shim to have OpenCV there on disk before JNI started, right?
Yeah.
So you can go and link to it. So there's just the fact that you can, yes, you have to run on a standard implementation. Yes, I have to run on a named version of Java provided by AWS, but you could do some customization. It's not like it's out of the box and you have no choice or options. You can. And
also, I mean, Andy's doing some pretty, more advanced hacky stuff over there. But even with a native Java runtime and with Node and with Python, there are these things called wrapper scripts where you can actually impact the argument when Python or Java or Node runs. And they are just, in fact, if you look up wrapper scripts in the Lambda documentation, you can add some arguments, for example, and it's basically what Andy is doing is replacing that shell script to do whatever you want. So Andy's doing some advanced stuff, but if you do want to do, for example, you want to track the import time. I was working with a customer recently, not really understanding how some packages were being imported and what was taking time. You can change the parameter when Python starts, -x import time, and off you go. It's going to be able to do that. And that's very easy to implement.
Yeah, and it's just just writing shell scripts.
Quickly. Also, just Brooklyn Man was talking about how you save 90%. You said $600 a month to keep the lights on. Is there a point at which it may be cheaper to use Fargate?
Excellent question. So right now, and I have, Julian, I don't know if there's a way for us to share files, but I have PDFs exported from the AWS calculator to capture. I didn't want to share like my invoices. Sorry. There's account numbers and stuff like that on there, but I shared the calculator, which basically captures the same information. I don't know if there's a way for us to share files.
Yeah, we can put that in the share in the notes one. We can host them anywhere, I suppose.
Okay. Perfect. Yeah. So I'll make sure that those are available. And there is definitely a point where using Fargate would become cheaper. So the nice thing about using API Gateway in the middle is I get to pick and choose what implementation to use on a per endpoint, per method basis, right? So let's say that one of the real drawbacks about running everything on Fargate is experimentation was expensive, right? Anytime I want to host a model for a new endpoint, I have to spin up a server to hold it. That means that every time I want to run an experiment, launch a new endpoint, try something out for a client, I have to pay money for uptime. That's a problem. Because if I make a bad bet, now I'm stuck holding bag, paying for a server that's just sitting there. So for serverless, that allowed me to go and put out a bunch of, that would in theory allow me to go out and put a bunch of experimental features out, and it wouldn't cost me anything if I made a bad bet, right? Yes, some time, right? Yes, a little bit of money to upload and host the thing in S3, but pennies, right? Not a big deal. If one of my endpoints gets just red hot, right? Yep, found it. This is it. This is what everybody loves. Everybody wants it. Let's, 10x our rate limits and start really charging real money for it. Then in API Gateway, instead of pointing it to Lambda, I could just for that one endpoint method go and point it out to a set of Fargate servers, right? That were spun up just for that one particular model. And then if I was able to make some kind of, if I was able to get some kind of warning, or if there was just kind of a regular rhythm to how people used that, I could also have like one server per availability zone on demand, or even through a savings plan or reserved Fargate, and then the rest could just be Fargate spot.
Yeah.
So there's definitely times when you can do that. But the nice thing about using serverless and API Gateway is that I can pick and choose exactly which implementation strategy to use.
Yeah. Excellent. Well, as we quickly coming down, Brooklyn Man, super useful to see a real-world implementation of SnapStart in use. Thanks again. I thought it was fantastic. Before we say goodbye
really
to Andy,
conversation.
Next week, we're going to be talking even faster kind of things. So we're talking about Richard Davison's incredible Lambda low latency runtime, LLRT runtime. That's on the 26th of March, same time, same place, because in the US, it's still 10 a.m. Pacific, but the rest of the world, it's a slightly different hour because the clocks aren't synced yet. So just remember that. But yeah, super fast stuff. And don't forget, we're also going to be talking about EDA Day in London, May the 14th. We'd love to see you. And serverlessland.com, all things to do with serverless on AWS. Andy, I want to thank you for your time. That was absolutely fantastic. Shiltube is as excited as I am. So much content pushed into that. High usage of Java on Lambda with Fargate, with step functions, with everything thrown in. You're a wizard. We appreciate all the...
Very much enjoyed the conversation. Thanks so much for the invitation.
Cheers, Andy.